application looks like. Enter AGPI. The first thing you'll typically do, I have some data already. So what I will do is I'll start with the beginning so that I will clear my test data and then I'll try to recreate everything. I'll seek the database again. So what I'll do, I go sim and I go wipe all plus raw, wipe all data, raw telemetry and everything, wiped all plus raw telemetry. If we, once I do that, you can go back and check. Everything is zero. So everything got wiped out. There is nothing. Label Q empty, causality, action, everything will be empty. So that's all you have to do to start to get a clean slate. Just click wipe all plus new. Uh, if you click this, then only the episode table gets wiped. But this is the better one, which can give you clean, everything gone. Then the default settings are good. Just go and hit generate new, generate raw. So now you'll see that it will give you some status. It will tell you that this something got created. So if you want to, you can after this you can detect some violations, but this is a read only. It doesn't do anything. It doesn't write anything to table, but you can see it that it did something, right? So I did detect. It says detect violation. It gives you the JSON, how many detection it found, what did it find. It is a histogram, 0 to 1 minute, how many this, that, all that it is telling. Okay. So then, like I said, that's an optional step. What you want to do then is a create episode. And make sure that this is checked. If this is checked, then you don't have to do then see the action. This will actually create actions also. After that, you go and just click create episodes. See, you'll get all this message. So if this comes, that means it's all good. So now, if you go back to the dashboard, you will see that it has created, few episodes. How many? About 13 episodes looks like. Yeah, 13 episode it created, and 167 violation, 13 episode, last 60 minutes, there are 21 episode like that. Violation per minute, this is the average per minute, about 0.35 episode it has created. It's a scatter diagram, so it tells you that for this severity, that this is the frequency you're getting. So we will have a separate talk on what a scatter diagram means in this context, but here it is. And it can be queried on various ways, by SAT ID, by satellite subsystem, by class, by fleet, like that, by priority, status, all that filter option is there. Let's pick one of the episode. If you click here, let's say this episode, it defaults to the RCA. The most important tab is the RCA tab. It tells you the root cause analysis. And now this root cause analysis is it takes a lot of factor into coming to this root cause. It looks at similar incidents. It looks at a fleet priority, what is the fleet prior, not priority, fleet prior. So bunch of other things and then it comes to a root cause analysis. So it will give you that, what is the various root cause, and it explains you what these root causes mean. So this is the most important RCA. You can go to the ops tab. It tells you a few other stats about the episode. Episode is nothing but a time window on which a critical number of violations have happened. So let's say it's a 15-minute window, and then it should have at least 5 violations. Then it will count it as an episode. If it's a one-off violation, it is normally not treated as an episode unless it's a critical violation, like something like a voltage dropping sharply. Those have been defined in the system as a critical violation, and then that even one violation, it will trigger an episode. So then, there's this insight. Insight is mostly about the machine learning that powers it, like this a physics residual. It uses a pin network, physics informed neural network, to see if there's any physics invariant, the laws of physics should not be violated. If it sees a physics law violation, it flags it as an anomaly. So law of conservation of energy, momentum, angular momentum, like that. All that is factored in, conservation of charge, all that is used to create this residual. You can click on it so see all the detail. You'll see that mostly it is healthy. So there is nothing, physics is not violated in this episode. So we're leaving it alone. And this GRU is like temporal. VA is any novelty that you see in the data, like any unusual pattern, any unusual cluster. This thing will tell you. And then twin residential is like, we have a digital twin concept also here. So that is also is there. you know um, so this is the next important insight menu. Then similar incident, like I said, similar incident plays a role in creating RCA. Like what is the root cause analysis, it a similar incident has a weightage too. So then you can see like what other episodes are similar to this. It uses like very complex, like fingerprinting, vector, embedded vector, etc., to figure out what similar incidents are there. It is meant to capture the institutional knowledge over time. So any of the past learning is not lost. So let's say we troubleshooted episode one, and whatever learning that this latest episode can refer to it and learn from it, and then get some weightage from. So that is um, the benefit of a similar incident. Similarly, there's a telemetry tab. You can see all the telemetry. You can see that voltage here is not a problem. Always in the 16 volt, like very well charged, so not a problem. I charge, like P solar. There are these. So anything irregular trend, you'll immediately see it here. If there's a spike up or down, it will be visible here. So that's why this telemetry tab is there. Then active learning is for, like when the human in the loop, like, if there's like these machine learning models are inconclusive, or the RCA is very close, there are like more than one explanation to it, and then you want a human to finally decide something. So then active learning, a human can come and mark it with the opinion that, okay, this is true, and submit an evidence. Similarly, the root cause, they can do like what is the root cause in their opinion. It's a human override, basically human in the loop. So that can be done here. And then we build all this human insight, and over the years, this insight can power like more machine learning, right? We don't have to rely just on physics model, VA, GRU, all that, but we also have the human input now, which again forms like institutional knowledge, right? Do it long enough, and now all whatever human has done is now being tracked by the system, and the system is getting better over time. This is the graph context. Graph is the knowledge graph, So this is one, like picture is worth 1,000 words. This is the episode, like we are talking about this episode in question. I think we took episode one or something, whichever episode it is. So it is at the center. On the left, you will see all the signals that this episode consists of, like the violations, the evidence that we have on this particular episode. They are listed on the left. On the right, you will see like the root cause analysis we did, that shows in the right. And this is at the bottom, you'll see is the similar episode. What similar episodes were found. And you click any one of them and it will tell you like what that is about. So this is like very rich information, all in one picture, right? And then at the extreme right, you'll see the action. So for this, what is the action the system is recommending? It is telling enter safe mode and then do an EPS reset. So that is what, based on all the knowledge that this complex system has, it is giving you an action. So it saw certain violation. Now it is informing the operator. So once you have that, like you can go and then see, right? So now graph context is telling you the action this should be taken, or it has its recommendation. You can actually go and then record that action here also, like um, so here, um, yeah. So coming back here, I think I lost the chain somewhere. So here is the action. Yeah, for this particular episode, this is the action, and this again allows us to record the option, the action that was taken, and then you can say take the action as now that I just took it. But then I think sometimes it makes more sense that you are trying to log the action from when it was actually taken, which would usually be within the episode time. So if the episode was 30-minute long episode, then you typically take the action during the episode. If the system is prompt, you can do it this, or you can pick a custom window. So there is a date picker, time picker. You can actually tell it when was the action taken. So you take the action and then you just simply say, I can just say now and just say record the action. And now you'll see that one additional action will be logged against this particular episode. So as easy as that. So if any extra action was taken, then you can just simply come here or this, and then you can look at causality, right? What you can load the timeline, and for this particular episode, if you want to get like more detail, what really, so if you load the timeline, it will tell you that this episode had like 18 violation, mostly solar not charging. So why he's not solar charging, right? So this is it. And so it tells you, and then 6 actions were taken to solve this. EPS reset, safe mode, again a EPS reset, then again a safe mode, and like bunch of whatever action we have taken historically is all listed here to deal with this kind of episode. So that is that. So I think I've explained all the tab here. What is the causality? And see, we are saying EPS reset most of the time, and you'll see the root cause analysis would actually confirm it. EPS solar not charging, all this. And then um, I think like then charge. I think yeah. Okay. So we probably missing another screen. We wanted to do like like there is a rule engine that tells you like what action to take when, right? So when this happens, so currently this is only showing the cause. It is not tying. This screen is not tying to the action. For what action, you have to actually look at the graph context that actually tells the action. And probably in the newer build, we'll have that where we can actually connect. We can say that action is what was actually taken, and we should probably have something called recommended action for this kind of RCA. So distinction, action is what actually was done, and recommendation is what the engine recommended that you do. So probably like right now that distinction is lost. We'll probably add that action, or what is that recommended action there. It will tell you, and so this and yeah, and so this is load the timeline, tells you what the violations happened and what was the action actually taken. So it is a log of all the action taken for that episode. So yeah, that is at the episode level thing, and then there are few things which are at the like there's a label queue. Label queue is where you see that uh, system is asking human, like there's some ambiguity here. Can human, there are some heuristics or rules based on which it decides to put few things. Like episode 2, it probably had clarity, didn't ask it to be labeled, but other, they meet the criteria and it will put it here in the list. And so system wants it human labeled, so it will put it in the queue. And you click on it, and so you can then human can then submit evidence, right? Because it has asked, I can just submit a true submit evidence. So now there is some, I've taken some action. I can also say root cause it was this, submit level, and I'm like 95% confidence I can submit another episode evidence there. So that will go. Now if you go back and you'll see that episode 1 is gone. It is gone from the label queue. Why? Because it is no longer an open episode. Like I actually, like as a human, I reviewed it, and we now the system will treat it, keep it in its record that this is what the human said, and future machine learning model will pick on it. And that's the purpose of this label queue. The queue sim, we already talked about it. This one thing about sim to note is that you can generate not just normal signal, but actually something like a special, like like a RV on Eclipse. You want to create telemetry like that, you can create. RV, the payload active, true or false, you can do. You can say in Eclipse and payload active, and you can do like, and the current temperature is true. So whatever permutation combination you can put it here, you generate the raw. It's a great simulation engine. And then like you can also like nudge the system, like how, so like there's a physics model that drives it, like what should happen in Eclipse when the payload is active, when the temperature has this, there's a spike. So it can create a telemetry, but sometimes you want little deviation from it. It look more like a real system, where real system doesn't always play by rule. So we can give it a nudge. So raw means, no realism, but you can do nudge only or nudge and soft, like, soft nudge. There is a, you can nudge and then there's a soft nudge, soft nudge is even, um, soft scope is like solar only full. So there is a distinction between soft nudging and soft constraint. Like you can actually force certain constraint. That is the soft only. You can put some force constraint. So the point being that this is a very advanced simulation software. You can nudge means, like, and there's a degree. You want a light nudge, a medium nudge, or a harsh nudge. Like, do you want to deviate it too much beyond the normal science and what is understood? So what it will do, it will help us stress test. If I want to do good heavy stress test, like how does it the system behave when it is heavily, like, running very extremely low voltage or extremely high running temperature, or all those charge, something, all that, like those signals gone horribly wrong. So you can create like that. Um, I think I've actually forgotten the soft only. What was a good example of a soft constraint? So I'll have to probably come back that look at the documentation of the soft only. But there's something similar, right? There are two kind of thing. One is nudge, the other is soft constraint. So I'm sort of blanking out here, so I'll have to see, and then what is in the soft constraint. And yeah, so simulation, we already know. Admin is where all the open level requests are here. So we can do like all the open ones. So 3, 4, 7, they are left. And then the ranked causes are also here. Like, so if you pick an episode, let's say the current, so this is another screen that if I pick episode 2, then these are the rank causes. But the purpose of this is, like for the admin to request a human review. So let's say human wants, uh, like uh, like this episode, which was actually closed, it should be put to human review. Okay, so they can go there and just say number 2 and then request human review. So now you will see for episode 2, now it was a closed episode, but we forced it. The admin can force and make it open again and ask the human to review. So now this thing is now, episode 2 is open. So you come to dashboard and go to episode 2 again. Here it is. Now human can go and then take the active learning thing, right? So again, human is being asked to give some more evidence. They say active was actually true. Submit evidence, like that. Root cause, category, there are things or severity can be noted, or this the root cause is specified again, unexpected load, let's say like that. I'm submitting the level. So now you'll notice that now episode 2 is no longer, it will say that it is no longer open. Like, if you go there, 2, there is no open because we just answered it. So this is like the admin, like, can request some other user to go and label it. So that's what the admin is doing. Causality is like at a fleet level causality, like, you can see typically, like, there are some presets. We should get rid of brownout. So let's say I don't want to, like, I just want to keep it blank. Or you can do something which is actually a valid violation type here, like battery low, EPS bat low, that it will take. But the brownout, there is no raw telemetry yet. So just hit refresh and it will tell you. So the thing to note is that this is at the fleet level. And sometime we can talk about our why the fleet causality is important, because it helps us set our machine learning for a fleet prior. We can learn from the fleet and then do some kind of transfer learning delta calculation and apply it to that system or satellite in question. So this is the fleet level aggregate. That is what, it goes here, and it shows you like how much data it has for the fleet. So enough data, 50 data for the fleet, and so an ML model can run on it. So that's what that is. And demo just basically tells you, like, which sequence you should run this application to get familiarity. So yeah, so I hope it was clear.